Welcome to Fast Math Solutions on Maths with EJD. And in this particular video, I'll be treating the question you have right there. Given the PGF of x as g of t equals 1 over 5 into t plus t squared plus t cubed plus t raised to the power 4 plus t raised to the power 5, obtain the expectation of x of raised to power 4. That's like the the fourth moment of random variable, you know. So, and then B, we have something that is a bit not quite connected with that, and that is to define the state, what is meant by state transition matrix. So let's go on to do that. Okay. So to take care of the first question, right? So to obtain the expectation of x raised to power 4, given that the PGF, given that the PGF of x is g of t, that's the probability generating function of g of x is g of t, which is 1 over 5 into t plus t squared plus t cubed plus t raised to power 4 plus t raised to power 5. So we have to do that. So one thing you need to understand is that the art the art moment of a random variable like x is a random variable, right? So the art moment of a random variable like x, okay, let me say random variable x is defined as the expectation of x raised to power r. So in our case, we need our r is 4. So the art moment is defined as the expectation of x raised to power r, and that is the art derivative of g of t, where g of t is actually the probability generating function. That means you're going to look for the tr of g of t, and that you will evaluate at t equals 1. You know, when we are looking for the expectation of x, right? That is, we differentiate and then we evaluate at t equals 1, or whatever the variable is. So in this case now, it's clear that g of t is the probability generating function of x. You know, that's generally speaking. So you have this now, and that's very important to what we have to do. So if you're looking for the so if you're looking for the expectation of x raised to power 4, then that means you're talking about the fourth derivative, or simply let me just say G4, the fourth derivative of the probability generating function, that is d4 dt4 of whatever g of t you have, g of t, and then you evaluate that at t equals 1. So then we have to refer to the g of t now. So the g of t we're given, as you already know, is 1 over 5 into all that is 1 over 5 into t plus t squared plus t cubed plus t raised to power 4 plus t raised to power 5, like that. So that now so you need the fourth derivative. So you can start. The first derivative is 1 over 5 into, differentiate t, you get 1. Differentiate the next one, you get 2t. Differentiate the next one, you get 3t squared. Differentiate the next one, you get 4t cubed. And lastly, you have 5t raised to power 4. That's the first derivative. Don't forget, you're going to the fourth derivative. So the second derivative, that's g prime prime of t, is equal to, or better still, let me use the numbers directly the way they are so that you can actually link them together easily. So g2 of t, that's the second derivative. So that is again 1 over 5 into differentiate one, now it's gone. So 2t, you have 2 plus 6t plus 12t squared plus 20t3, like that. So talk about the third derivative. The third derivative, you have 1 over 5 into 2 again is constant, so it's gone. So you have 6 plus 12 times 2, that's 24t. And the next one is 60t squared. That's 20 times 3, 60. That's the third derivative. And then the fourth derivative, what we actually go into, because we need the fourth moment of the random variable x. So that's 1 over 5 into differentiate 6, that's gone. Differentiate 24t, you have 24 plus differentiate 60t squared, that's 120t. So now that you have this, so you need to remember that you need, okay, let me put it this way now. So you remember that the expectation of x raised to power 4 is actually the fourth derivative of g of t evaluated at t equals 1, okay? So that means that you have 1 over 5 into 24 plus 120 into 1, like that. And then this is 1 over 5 into 24 plus 120. And then that results to 1 over 5 into 144. And then that is equal to 144 divided by 5. So that is your expectation of x raised to power 4, which is the same thing as the fourth moment of the variable, of the random variable x. So that ends that particular question. Then the second part of the question, we need to define the state transition matrix. Okay, that one is just it's more of maybe stories and maybe a kind of general expression like that. So, we talk about state transition matrix, state transition matrix. Let's mix that up. State transition matrix in the context of Markov chains. So, I mean, along the line, we'll get more clarity on the idea of Markov chains. Maybe I'll get to teach about that at some point. So, you should know this, that that in the context of Markov chains, right? So we are talking about state transition matrix, transition matrix. Of course, there's some kind of movement going on here, and that is what we have. So talk about transition matrix now. So you should know that in the context of Markov chains, in the context of Markov chains, a state transition matrix, a state transition matrix, a state transition matrix is actually a square matrix. It's a square matrix, maybe 2 by 2, 3 by 3, and so on. So it is a square matrix that describes the probabilities, that describes the probabilities of transitioning, probability of transitioning, right? From one state to another, in a finite number of steps, that means that you have a given number of steps. It doesn't go on indefinitely. So in a finite number of steps, okay? So that's what a state transition matrix is. Now to make that clearer, right? So we can say that if there are n states, right? If there are n states, the state transition matrix, the state transition matrix, is an n by n matrix, all right? Okay, so to add more clarity to that, I like to give a kind of example of what this looks like. So let's denote the state transition matrix, the state transition matrix as P, where Pij, where Pij represents, the probability, the probability of transitioning, from state I to state J, that's a movement from one state to another. Okay. So now we can say that the properties of a state transition matrix, transition matrix are the following. Just two. They are: one, it looks very close to what we said about PDF in one of my previous videos. So each element Pij is a non-negative number, It's a non-negative number, right? And then the other part is, so we have this non-negativity and the total probability equals one thing again here. So again, the other part is that the sum of the elements in each row of the matrix is actually 1. So when you sum up things in a row, you actually get 1. So in mathematical terms now, I guess I need to change marker at this point. So in mathematical terms, right? In mathematical terms, you can have your transition matrix P. Okay, let me just do this so that it can go well. So we have P11, P12, all that up to P1n, and then you have P21, P22, all of that up to P2n, and then of course everything goes on, and then you have Pn1, Pn2, all of this goes again, right? And then you have all that up to Pnn. Of course, this also goes, and then you have this, something like this. So that is a transition matrix P, which you can just say is P equals this. So that's the transition matrix P, right? And we already know where the Pij's, each of them is greater than or equal to 0, because no probability is less than 0 and greater than 1, none. So for all I, comma j, and we know that the summation of Pij for j equals 1 to n. So j equals 1 to n talks about, this is row and this is column. So if you take it for column, you get 1. If you take it for row, you also get, okay, especially for row, right? It's always 1. So summation Pij from j equals 1 to n is always equal to 1 for all I. That's for all rows. So that's basically what the idea of it, state transition matrix is. So with that, we come to the end of this question. If you have not subscribed, be sure to do that. Hit the notification bell so you can get alerted anytime anytime I upload a new video. Then be sure to like, comment, and share. Some people would need this to really to help them with some difficult tasks. So you want to be that person that helps them to get connected with this. And of course, you can make comments about problems you like me to solve. Like this particular problem is someone requested for it. So I get to do that as I get time to do it. So please do all of this and let's continue to have a nice time doing maths together. Okay. So see you in the next video.